Hey, this is Steven from RC Engineering, and welcome back to my development series. This is development video number 3, and this is going to be one of the last videos we're going to do on this RC thrust stand as far as development before we do it in our analysis series. Again, the analysis series, until I get the $20 a week from the Patreon subscribers total on my Patreon, will be a addition to the development series. So the analysis series, and if you want to make that happen to where the analysis has its own series and I do one a week, go ahead and head to my Patreon and check that out to see how you could help make that happen. So I do that the third week of the month. So we have, obviously, I'm going to say we're going to have 4 weeks in a month. First 2 weeks are development videos. Third week is analysis video. Where basically I take something that we do in the development videos, or I take something from the general videos, which I do once per week, or I take something from Rule of Thumb and apply it. So basically apply something in the development series or from my general videos in real life in RC modeling. So for example, one coming up would be using what we learned in the propeller Rule of Thumb series, which was last week, was the last week of January, and then use that on a RC plane to get faster speeds, let's say. So that would be an example. In this case, it would be we're going to run this guy and see if we could get thrust out of it. You know, do some testing of some motors. For example, I have here some 6mm, 7mm, 8mm motors. 8.5mm motors. I don't have any 10mm motors, but yeah. Okay, so getting pretty close here to midnight, so I want to get this of 2/4/2018. So I want to get this video out here pretty soon. So we're going to look at finishing this guy up, polishing it up, and getting ready to print. I now have a Cetus 3D printer, so that's a slightly bigger bed of 6 inches. So it's a 6-inch by 6-inch, and I have the extended here, so it's about 8 inches or so tall, 8-9 inches tall. So definitely, obviously, going to have an upgraded bed, but I think that the Trinus prints way better than the Cetus, but that's my personal opinion. Okay, so let's go ahead and look at this guy and clean anything else up that we need to do. Let's pop out really quickly here while I continue talking. Let's pop out one of each motor so we can go ahead and take some measurements, and then of course we're going to assume that most of the measurements are going to be like this. Then kind of how the process is going to go is after this video series, I'll print this guy on the Cetus or the Trinus, and we'll print it out and we'll make adjustments from there. Print one part out one at a time to make sure they fit, and then make adjustments, because generally that's how you do stuff in 3D printing. Because when you do 3D printing that has things that fit to things in real life, not fit with each other. Generally, if you have things that fit with each other, you generally only need to print once. What I mean by that is if you want something to fit with something that's printed on the same printer, generally you could print it all one time and it'll be fine. However, if you want to print something to fit with something else in real life, generally you have to print multiple times, because you have to deal with expansion and contraction of the filament causing problems. So we're going to be checking the dimensions of these motors to make sure to take a look at what size they are and how we can best fit that. Give me 1 second. I need to start an upload here. Yeah, there it is. That's the video for this week's general video. By the way, it's about flying that T-28 Trojan. The T-28 Trojan from Flightworks. That review is this week. Okay, so we have all the motors out. I'm also uploading a video at the same time, taking about 25 minutes. Okay, so what are we looking at here? So 8.5mm motor is 3.35, and I'm going to add 30 just like we did. 3.35 plus 30. Okay, so that's good. I like that. This one, 7mm, is 2.75 plus 30, so that's 305 around there. 0.305. Okay, 0.306, I like it. And last one is, and the plus 30 is for expansion, compensation for expansion, which I find on most printers is about around 0.30. 0.236, so that's 0.263 or so. 0.263, okay, 0.266, that's fine. Alright, so that's looking good. And another thing that I wanted to do was I wanted to extend this a little bit taller. Because one of the problems that I found is that obviously because the motor's in there, this guy's not going to slip on there too far. And also it's going to cause problems with distancing. So let's say that this is actually 0.6. And we want this guy to be towards the bottom. But another thing we could do is we could have it there and then this guy would be pushed up against it. That's fine. And the other question is, how are we going to attach that to this? Probably hot glue starting out. So let's just make that adjustment. We'll run with that for right now. So that was 0.6. So we'll also make 0.6. And let's see, does it still have the marking? Okay, cool. Because we want to run a, we're going to run an assembly, so we can learn about the assembly. Okay, so let's start a new one, and let's call this the thrust stand assembly. This is where we're going to assemble all of our parts. So let's go ahead and you could drag and drop in Fusion 360 to drag and drop the assembly inside. And when we do that, we're going to stop it. And we're going to do some assemblies. So what we're going to do is we're going to take a look at some of these things here. I'll take that guy. See, here's the other problem, is that these are all of the same material, so it makes it very difficult to change it. What these should have been is these should have been in different files, each one in different files, so that way you could actually attach things to it, because these are all in the same file and it gets confused about what you're trying to do. Let's see if we could make, I wonder if we could do that. There are no components to assemble in this design. So here, when you go in here, you notice that this is all one component. And it's not going to let me it's not going to let me basically pull those apart. So we can't really run an assembly here, unfortunately. So again, like I said, the idea is that you need to make these separate so that they could kind of fit together. And also I noticed I didn't, oh wait, did I save it? Oh, I didn't save this file yet, that's fine. There it goes. Alright, cool. So yeah, so it should be pretty close. I mean, these obviously are butting right up against the motors. So this really depends on what you're doing. So what I can do, what I do need to make an adjustment of, is go to this first one. And I need to make sure that this piece, let's see here. So I'm going to do that. I'm going to project include, and what I'm doing now is I'm looking at where this guy is. This guy I want to be located right in the center, which that's a little bit low. Let's close this out. Okay, so let's find out. So what is the distance between here and there? Actually, let's make that marking. Oh, we're still in the sketch. Okay, so we need to increase it by 2.5. So let's find that extrusion. Yeah, perfect. Okay, so now we're perfectly in the center, so now when we push that guy in there, it'll bottom out and it'll be perfect. So now the main thing would be to print each of these guys and see. So what I'll do is actually I'll push this video to a later date. In the net, what I'll do is I'll do another one today, and this one what I'll do is I'll add a second part where where I print it, because this looks okay. We'll print it, and I'll talk about the things that I had to do to adjust. And today we'll do a different development video because I'm only 12 minutes in. 15 minutes to assemble and talk about it. So this looks good. We'll print it. Everything looks good. Everything's been double checked. We'll print it and see what's going on. And so I'll do a different one for the week of the 4th of February, and next week we'll print it and take a look. We'll print it on the Cetus or the Trinus, take a look at it, and I'll talk about what I changed and stuff to get it to work. Alright, so I'll see you guys in part 2. RC Engineering, and welcome back to part 2 of my part 3 brush test stand for my development video series. And we're looking here at the printed parts. So in part 1 we finalized the parts, and here in part 2 we are putting together the test stand here. And so here are the printed pieces. Here's the upright, and here is the part that presses down on the scale, and here is where our motor mounts. You see there the hole is slightly warped when this focuses, so we're going to have to drill that out, but that's fine. Here's the pivot, and something very, very important when you're 3D printing is to always have a piece of sandpaper so that you could hit this guy with a piece of sandpaper to clean it up so that they could kind of get rid of any sort of warpage. Another thing is when you're printing it flat, you get what I call you get like an elephant's foot, they call it, where it mushrooms out here. That's so you get a good adhesion to the bed. So that's a good thing to sand off first. Otherwise, the parts came out pretty good. I did get kind of this weird warpage right there. I don't know if you guys can see that. I think you guys can see that there on the left-hand side. But that was okay. I just sanded it, and then the motor fit right in there pretty quickly. So I'm going to sand this guy out a little bit. The pivot fits here pretty snugly, so I'm going to hit it with sandpaper until I get the clearance I want. Then this guy is going to be mounted a little bit higher than the scale itself. And next week we're going to do the analysis video. Again, first 2 weeks of the month are the development videos, and until I meet the stretch goal on my Patreon, there's only one video per month for analysis, and then the 4th video of the month is rule of thumb series. So this month is probably going to be a brushed motor. We're going to put a brushed motor in this guy and do some thrust tests on a scale. On my scale here that measures up to 1/100 of a gram, and we're going to see how that goes. So yeah, it came out pretty good. No real changes. Main thing I'm going to do is I'm going to see what fits in here. If I need to and I have something else around, I'll drill it out, put a different bolt in there that the shank goes all the way through and out the other side, and then put a bolt on it. And then that should be fine. Other than that, it's looking pretty good. So again, I'm going to lift this up on a piece of block of wood or something, and then this guy is going to press down on the scale and put a motor in here. Also, I have a few brushed that I've blown. Not really the best thing, but I've blown a few of the brushed flight controllers. I believe I've blown out both of the receivers so they no longer bind, but they do control brushed motors. So I'm probably going to mount that guy, and those are capable up to 10 amps. So we're going to have some fun with those. So we're going to mount that up to this guy and run them. Alright, so we'll see you guys in the next week's video where we run this guy and see how it turns out. So I'd like to thank you guys for watching. Please subscribe for more videos on my channel, and if you want to help support my videos, go ahead and head to my description. My Patreon is there for other free video content. I've been working on a lot of it. Haven't posted much of it yet, but I'm going to be posting a lot here soon. Go ahead and head there, whether you feel like backing or not. There's a few pieces of free content there for you guys. Alright, so I'd like to thanks for watching. I'll catch you guys in my next video. Take it easy. Peace.